Hello, my name is Jorge Cano. For my telecommunications foreign navigations final project, I am going to present ACARS, Aircraft Communication Addressing and Reporting System. ACARS is a digital data link air-ground communication system for transmission of short messages between aircraft and ground stations. It is used for transmission of air operational communications and air traffic control information. AOC is the communication between the airline and the pilot to share flight information and operational information to ensure an efficient coordination of the airline. ATC is the communication between the air controller and the pilot, which objective is to organize the airspace and prevent accidents. ACARS is provided by Enric and Sita companies. Prior to the introduction of data link in aviation, all communications between the aircraft and the ground personnel was performed by the flight crew using voice communication, using either VHF or HF voice radios. In many cases, the voice-related information involves dedicated radio operators. In an effort to reduce the crew workload and improve the data integrity, the engineering department of Enric introduced the ACARS system in July 1978. The original expansion of the abbreviation was Enric Communication Addressing and Reporting System. Later it was changed to Aircraft Communication Addressing and Reporting System. But ACARS did not experience widespread use by major airlines until 1980s, and it was only used for AOC communications. In the beginning of 1990s, with the apparition of FANS 1A and its posterior generations FAN 2B, started to use for ATC communications in pre-departure clearances. It was not until middle 90s when was started to be useful for ATC. For example, the full coverage of Europe completed in 1995. ACARS experiment day by day a growth in its use due to the increasing number of flights and the increasing level of automatization of the aircraft. But how ACARS works? When a certain message wants to be transmitted from the ground to the aircraft, there exist several possibilities depending on the situation of the aircraft. Via very high frequency link with basis on VDL mode A, called also the old ACARS, or based on VDL mode 2, called ACARS over AVLC. Via high frequency with the HF data link, or via SATCOM, satellite communications, in which we have two ways of communications, using Inmarsat services or using Iridium constellations. VHF first option is using VDL mode A. It is only used for AOC communications due to several lags on the connection, as delays that make useless for ATC information, that requires a fast response. However, it is widely used in continental areas because needs a direct line of sight between the antenna and the plane. The ACARS channel access method is a carrier sense multiple access algorithm that requires a station to verify that the VHF channel is free before transmitting. That permits a maximum rate of 2.4 kilobits per second, reduced to only 300 bits per second in congested situations. The VHF aeronautical communications goes from 180 to 137 MHz, dividing the bandwidth into 760 channels, with only 8 are reserved to ACARS communications. As base extensions are required to establish the link, the space is divided on different sectors or cells, with different channels than the adjacent cell. Each of one has a coverage around 320 km away for an aircraft at an altitude of 30,000 feet. The second option is using VDL mode 2, which one of its parts is ACARS over AVLC, Aviation VHF Link Control. This system uses a DH-PSK constellation that improves the characteristics of VDL mode A, maximizing the data rate until 31.5 kilobits per second and reducing a little the delay, but not enough to use on ATC communications. The high-frequency data link is used for AOC communications and ATC information in remote areas, because traffic control on areas with low traffic density do not require such as velocity of response. It is used on oceanic communications, where there is no direct line of sight and the signal of HF can bounce on the ionosphere to reach its destination. The use of phase shift keying or PSK allows a maximum rate of 1.8 kilobits per second. The frequencies used change from 3 to 30 MHz depending on the environmental characteristics, as season, weather, or hour of the day, that modify the characteristic of the ionosphere. This connection can reach until 6,000 kilometers. Inmarsat is a geostationary constellation of satellites that operates at an altitude of 35,863 kilometers, the geostationary orbit, that allows a global coverage of ACARS communications. Inmarsats use L-band and S-band to send information to the aircraft using X25 protocol. The Inmarsat service is divided in groups. The ones that can be bought by the airlines are AeroH and AeroI, which offers different data rate. Iridium is a constellation of satellites that operates on low Earth orbit, or LEO, in L-band from 1 to 2 GHz with the aeronautical sector. Iridium deploys other services operating in Ka-band for other purposes. It uses a frequency division multiple access modulation that allows a duplex communication between satellites and aircraft with a bit rate of 50 kilobits per second. Once the message is sent, how does it go to the pilot? When the message is received from the ground, with the VHF antenna or with the HF antenna, the digital signal goes directly to the management unit. In the case of receiving via SATCOM, the aircraft has to be equipped with the satellite data unit to communicate with the satellite. When the message is received, the satellite data unit sends information to the management unit. From this, the information is sent to the Digital Flight Data Acquisition Module, which interprets the signal and offers to the pilot via Multifunction Control Display Unit. All the movement of the message signal is performed by A429 bus, a standard bus used in most of the modern aircraft. If the message bounces on the plane, the message performs the same manner but on the other way around. We are not going to go in depth to the protocol architecture of ACARS. We must know that all protocols are standardized by Airline Electronic Engineering Committee. This committee is organized by the ENRIC Industry Affairs Department, but its voting members are airlines and its standard groups are open to any interested party, including CETA. You can find all the details of the standards at Airline Electronic Engineering Committee 618, 619, and 620 documents. What type of messages are sent through ACARS? It is usually to send operational, as OOOI, delay reports or position reports, dispatch, as flight plans, weather reports or weight and balance, maintenance report, engineering, as the engine data or the clock update, custom service, the passenger and crew, or connecting gates, catering request, and exceptional free use messages. The ACARS message is only composed by a maximum of 220 ASCII characters, so it only contains text. However, application developers have found ways to encode computer data very efficiently in characters, so that a lot of information can be transported in the message, that have an average length of 225 characters. As the system is digital, the real signal represents a chain of 1 and zeros that are decoded to a chain of characters and numbers that contains the information. The position is fixed, so the information can be classified and displayed easily. Now we go to the real world. We have interviewed some of the users of the airspace to know what represents ACARS for them and how affects its work. We are going to start with a commercial aircraft pilot. ACARS help us to communicate with the controllers and with the company. There exists some piece of information that is better to be displayed on a screen for avoiding misunderstanding and save time. The better example is the use of ATIS information, but we use most for weather requests or to refresh tracks on oceanic operations. As pilot, I use ACARS less than I would like to do it. In my opinion, airlines should make an effort to spread its use in everyday operations. The pilot's opinion is that the display information is better. They use ACARS for weather requests and oceanic tracks, and they ask for more speed of the system. The next one will be the air traffic controller. ACARS is more used for AOC information rather to ATC. We use normally ACARS to organize the oceanic traffic, which is less congested. For us, it will be easier to control the air traffic space via data communications instead of voice communications, because it is faster and easier for us, and avoids any confusion and ambiguity on the message. I hope in the future this system or a similar one could be widely used on areas where the airspace is very crowded and the air traffic control becomes a real challenge. Air controllers use more ACARS for AUC information. It reduces the ambiguity or confusion on the message, and he doesn't use for crowded areas. At last but not least, we will listen to the engineer. For engineers, ACARS represents an improvement on the air-ground communications in terms of operation and technical information, being able to get this information from the aircraft prior to the landing that allows us to prepare all technical issues. ACARS means a step to the future where data link communications will impose over voice communications. This system will increase the efficiency of the communications, that is translated into an increase of the capacity of the system, that will allow us to take up all the growth that the air navigation system will suffer in the following years. For the engineer, ACARS means faster information, a step to the future, and an increase on efficiency. Let's analyze the pros and cons of the use of ACARS in the nowadays airspace. In favor, increase the capacity of the telecommunication system, reducing the time of transmission of the information compared with the voice communication. Also reduce the workload of controllers, pilots and companies, helping to simplify the communication channel. It is widely used for AOC information on every stage of the flight, and it is fully implemented on FANS 1A and FANS 2B in oceanic ATC communications. The main disadvantages of the system are: it is not standardized by ICAO because it does not fulfill some requirements in its use in the congested areas. The system suffers big delays due to its large trip the signal has to travel to reach its destination. The message has to go through the ACARS DSP that are situated in Canada and Singapore. And as I have mentioned, it is not recommended for its use in congested areas. Some curiosities about ACARS. Honeywell developed the Secure ACARS to satisfy the commercial airline industry needs for ACARS security solution based on recognized industry standards. For military applications, Honeywell expanded the security protocols to satisfy the military operational needs for information assurance. Both the military and commercial Secure ACARS offers the flexibility of users to configure security policy, and once configured, operational is fully automated and transparent so that there is no impact on pilots, aircrew, on controllers' workload. The flight MH370 is the Malaysian aircraft that disappeared the last 8th of March. As we have listened in the media, the authorities could calculate where the aircraft fall down into the ocean. The supposed threat was calculated thanks to the position calculated with a geostationary satellite. The satellite was an Inmarsat satellite that was partially connected with ICARS to send its information. So, we can say that thanks to ACARS system, the authorities know where to start looking for the aircraft. For the future of air-ground communications, we can say that data will impose over the use of voice. There exists a tendency to implement the IP protocols in the current airspace. So we can say that in the near future, IP will help us to improve the interoperability of all the systems involved in the airspace. For the far future, the concept of SWIM, System-Wide Information Management, is acquiring more importance. This concept aims to group all the systems to deploy the right information to the right user at the right time. SWIM can be compared with a cloud where all information is stored and the authorized user can access to them whenever he needs. Thanks for watching. I hope you enjoyed the video. You can leave your comment just below. See you soon.